Okay, we're going to do problem solving with quadratics here. As I read a question instead of writing it out, a stone is thrown into the air. So we got somebody here, okay? And they've got this ridiculous stone in their hands and they've thrown it into the air. It just so happens that when we throw things due to gravity, they pretty much follow a parabolic or hyperbolic, we're not talking about hyperbolic shapes, but parabolic, which means a parabola, flight path, okay? So here's the stone, he's throwing it. Excellent graph. They said that the flight of the stone is represented by an equation of h at t is equal to negative 5t squared plus 30t plus 2, where h at t is height and t is time in seconds. And what was it in heights? Meters again. Whew, these people can throw very far. The very first question says, how high is this above the ground after 3 seconds? After 3 seconds, all we're doing in this equation is we're plugging in, instead of t for time, we plug in the number 3. We know what time is already, so we plug it into our equation. We got 3 squared plus 30 times 3 plus 2. Negative 5. 3 squared is giving us 9. Okay, so we still have to multiply that by negative 5. 30 times 3 is actually 90 plus 2. 9 times 5 is negative 45 plus 92. It actually gives us 47 meters. Wow. That's how high it is in the air. 47 meters. That's like 130, 140 feet in the air. That guy's got an arm. Okay. I think it's a little bit of an exaggeration, maybe. Who knows? I actually don't know how. Anyways, from what yeah, in feet, that's like, I think it's like 130 feet. It's usually, there's about 3, I think a little more than 3 feet in a meter, or maybe a little less. It's around that. So, yeah, that's really high. Anyways, from what height above the ground was the stone released? Again, this is the idea of, let's draw a graph. And because we're talking about time, the x-axis is not only going to represent the ground here, okay, but it's also going to represent time, okay? So if it's also representing time, we're looking for how high above the ground was the stone originally thrown. Well, this is our y-intercept. And our y-intercept is actually when x is 0, because we don't go back in time, right? We don't know what was going on with the stone before that. We're actually measuring from a specific point in time when it's thrown. So it happens to be thrown at 0 seconds. So we can do 2 things to solve this. We can go through the exact same process we did before, just saying h is at 0 instead, so we get negative 5. Okay, plus 2. And we know very quickly that 0 is just eat up everything else. Okay, any multiplication by 0 is just 0, and we get the height of 2. But the other thing we could have done is, if we recognize this was in standard form, whatever the c value is, that's the height. So it's thrown from 2 meters. That's realistic. That's about the height. I think it's about 6 feet in the air. Okay, so it's thrown from about 6 feet in the air, right around, height of somebody's head, potentially, if they're relatively tall. That one makes a bit more sense. And at what time or times is the stone 27 meters? Well, we know at 3 seconds, and I don't know if that's the highest point, this point, but we're just going to go out here and throw 3. We know it's 47 meters, okay? We also know that it starts at 2 meters. So this is definitely not to scale. So to be 27 meters, we're somewhere here, okay? So somewhere between 0 and 3, it's going to hit the 27 mark. And then somewhere after 3, it's actually going to come back down and hit the 27 mark. So luckily, there's really only 2 values only 2 natural numbers. It could be a decimal value. It could be actually any real number. I'm going to go on a guess here, and they've probably used whole integer values just to make it a bit easier for us. I do 1. I think 1's going to work out really nice. Let's try that. So at the time of 1, negative 5 squared plus 30 times 1, we'll zoom out a bit, plus 2. 1 times 1 is 1, times negative 5 is negative 5, plus 30, plus 2 is going to give us 27. Okay? So we know that time equals 1 second. We know the height is 27 meters. Our next problem is guessing the next one. We really can jump around a page on this one. We know it's something greater than 3 because due to parabolic shapes, 27 goes up to 47. That could be the vertex or the highest point, and it could come down, or it could continue to go higher. We're not entirely sure. So we could do stepping by ones. We could just say, I can try 4, 5, 6. But let's get a little risky and see if we can get the answer quicker. I'm going to go on a limb here and say h at 6, okay? Let's see what we get here. 6 squared plus 30 times 6 plus 2. And we're going to use our h value here to make an educated guess of our next guess. We're kind of trying to squeeze. This used to be known as like a squeeze method for proofs. 6 times 6 is 36. 6 times 30 is going to be 180 plus 2. I don't know if you have a calculator handy. I might need one for this part. Let's see, 30, 15, that's 180 it looks like. Ooh, is that right? 36 times 5 is 180? Yeah. So we get negative 180. Oh, so close. Plus 180 plus 2. We got a value of 2. Here's what's interesting. We know that that's the opposite side of here. Okay, remember at 0 it started there, so we know at 6 it got to that same height on its way down. So we know it's something less than that because it actually has to go higher. So maybe it's 5. And since our time was 1 second after the 2 meter height, if you remember, it was actually 1 second got to 27, it would make sense that it'd be 1 second before our 6 meters, or 6 seconds that it would be before. So let's try h at 5. Negative 5. And we'll learn methods to get to this much more efficiently. Negative 5 times 25 plus 30 times 5 is 150 plus 2. That gives, that didn't work out. Oh yeah, it's 27. Sorry, I was thinking we had to get to 0. Negative 125 plus 152 equals 27. There we go, checks out. So at 1 second and at 5 seconds are both of our answers.